Hi, let me introduce our prototype design. Our prototype includes two design features to scaffold the learners. The first feature is to scaffold with the hints to understand problem-solving strategy. The second feature is to prompt the students to reflect on the mistakes. Now, let's go through the overall flow of the prototype of the step loop adaptivity. This is a demonstration for one trigonometry question with two sub-problems. First, let's open the prototype. The question is shown on the screen for the learners, and then the learners will solve the problem on their own scratch paper. After the learners finish their problem-solving process, they are required to enter the answer for both sub-problems, and then they can submit to check their answer. They will do self-answer checking after they see the correct answer. There are three options for the learners. If they are correct, they will be directed to check the answer for the second sub-problem without wasting their time on going through all the hints and steps. If they are wrong about the problem, they can either get a second time to do the sub-problem again independently. For example, Lisa is wrong for this sub-problem. However, she thinks she can solve it out, so she redo the problem again. After the second attempt, she can either check her answer or ask for some more hints to get her through. If she still feels confused, the system will give her some step-by-step hints. The hint design demonstrates our first design feature. Scaffold students with hints to understand the problem-solving strategy. The hints are very detailed about the cases and formulas, targeted for this specific step, and the students can evaluate whether the hints are useful as well. Then, the process goes to the self-assessment part, which shows the second feature of the step loop adaptivity. For this part, the learners will first identify the mistake steps within the problem by selecting different blocks to identify the wrong steps. For example, Lisa was wrong in the last step. The answer should be pi over 3, but her result is pi over 6. And then Lisa will move to the self-reflection part. She will go through the solution and identify the mistake reason by selecting different blocks. For example, she selects the block I miscalculated because she calculated the result wrong. In this way, we offer her the specific prompts for her to do self-reflection about the mistakes they made in steps and the reason behind that. And then it goes to the next sub-problem to check the answer, which follows the same flow as before. That's all about our step loop adaptivity prototype. Thanks.